Okay, so we are almost done with this topic. We are just remaining with one part, which is the intersection of points. So once we are done with perpendicular lines, then we just have one part and we are done. So two lines are said to be perpendicular when the product of their gradients is -1. So let's say you have a line whose gradient is m1, then you have another line whose gradient is m2. When you multiply their gradients, you should get a -1. This negative is very important. So when you make m1 the subject here, by dividing both sides by m2, you have m1 is equal to -1 over m2. So this means when two lines are perpendicular to each other, then their gradients are negative reciprocals of each other. So in a case where you have been given one gradient, you can easily find the other by just getting the reciprocal and negating. So let's say the gradient of one line is 2. Then the gradient of the other line will simply be the reciprocal of this, which is 1 over 2, but negated. So it will be a negative number. Remember, the only time you can have a negative after multiplying two numbers is when the signs are different. So one must be positive, the other one must be negative. Otherwise, your answer will not be a negative number. So if the gradient of one is, let's say, -1 over 2, then the other gradient will be positive 2, because 2 is the reciprocal of 1 over 2. And then I'm not going to indicate the negative here, because when I get the reciprocal of this, I'll have a -2. And then once I put a negative there, my m2 will be +2. Remember, the product has to be -1. So when I multiply this by this, I'll get -1, which is what we want. So now let's look at examples. Find the equation of the line passing through 2, 3 and perpendicular to this. So this is my second attempt. I made the mistake in the previous video. So what I was saying here is, when you've been given y is equal to 1x plus nothing like this, then you can see that, and you're trying to write this in this form, then you can see that the gradient here is 1, and the c, which is the y-intercept, the point at which this line crosses the y-axis. So this is the y-axis. So if I was to sketch this line, it would look a little something like this. And because it is crossing the y-axis on the origin, it means the c is equal to 0. And then in a case where your equation was something like this, then your line would cross the y-axis at the point where x is equal to 3. So now, since this one is already in this form, our job is to take advantage of this and find the gradient and then find the equation. So to do that, we have y is equal to x, and then the gradient here is 1, so that means our m1 is 1. So to find the gradient of the line perpendicular to this, you know that you want a number which, when multiplied by this, will give you -1. So that number, m2, is the negative reciprocal of 1. But we know that the reciprocal of 1 is 1. So you just negate it and you have your gradient. Because 1 times -1 is -1. So we have the gradient, m is equal to -1. And then we have one of the points, which is 2, 3. Then you can just use any of your favorite methods which has these two to find the equation. So for the first one, I will use this. I want to use as many methods as possible. So my y1 is 3, my m is -1, my x is just x, and then my x1 is 2. So now to find the equation of this line, you can expand this times this, you have -x, this times this, you have a 2. Then you can take the 3 to the other side, -x plus 2 plus 3, so that your equation is -x plus 5. So in case you don't understand why we are saying m is the gradient when you express it in this form, we have talked about this in another video. So on the part B, this one has equally been expressed in this form for us, so this is good. So we have y is equal to 2x plus 3. So the coefficient of x is always the gradient. So if our gradient 1 is 2, then our gradient 2 will be the negative reciprocal of 2. So the reciprocal of 2 is 1 over 2, but it has to be negative because the product is negative 1. So now we have the gradient and one of the points. So let's find the equation. I'll use the gradient formula. You are free to use any method of your choice. Like this. So our y2, this is normally y2 is just y, and then our y1 is 3, and then our x or x2 is just x, and then our x1 is 2, like this. Of course our gradient is negative half. So now let's cross multiply and make y the subject of the formula. So we can just treat the numerator as the negative. You can't treat both. You can either put the negative on the numerator or on the denominator, but not both. So I'll keep it on the numerator so that my y will be positive. So this times this will be 2y minus 3, and then this will be equal to negative x minus 2. Then when we expand this side, we have this. We expand this side, we have negative x plus 2. Then we can just take the 6 to the other side and say plus 6. Then we have negative x plus 8, and you are done. If you want, you can make y the subject of the formula by dividing through by x, but it's okay to leave it like this. And then part C is a bit unique, but not really hard. So on part C, unfortunately, this has not been expressed in this form for us. So that's our job now. We have to make y the subject of the formula. To do that, you can divide each number by 3 so that y is all alone. So when you do that, you have negative 1 over 3x. We normally just write it like this, but it's the same thing. This is the same as this. Then plus 3 can go into 6 2 times. So as you can see, we have our gradient, our m1, which is this part here. So m1 is equal to negative 1 over 3. So now to find our m2, remember it has to be the negative reciprocal of this. So since this is already a negative number, this will automatically be positive. So the reciprocal of 1 over 3 is 3. So this is our gradient. This times this will give us negative 1, which is this. So now we have the gradient and we have a point 2, 3. So to find the equation of this, you can use any method of your choice. This time around, let's use the gradient intercept method. This is called the gradient intercept method, by the way, where this is the gradient and this is the intercept. That is the point at which this line passes through the y-axis. This is called the y-intercept. So with this method, you can substitute your x and y and your m, and then you solve for c. So our y is 3, our m is equally 3, and then our x is 2, our c is unknown. Let's solve for c. This times this will be 6 plus c. Then when you take the 6 to the other side, you have 3 minus 6, which is negative 3. So our c is negative 3. That means the equation will be y is equal to, you know your m, this is 3. You leave your x and y as they are. And then we know that our c is negative 3. So this is the equation we're trying to find. And then on part D, part D appears to be in the form y is equal to mx plus c. But when you check this, you realize that it's a negative. So that means it's not in that form. You have to get rid of that negative sign first. So you can do this by either multiplying everything by -1 or maybe a negative sign, or you can simply divide throughout by -1. So once you divide this by -1, you have a y, this you have -2x, this you have -1. So now this is in the desired form. So from here we can tell that our gradient m1 is -2. So to find the other gradient, you can just say m2 is the negative reciprocal of this. So since this is a 2 and it's a negative number, the negative reciprocal will just be 1/2. Just like this. You don't need to put a negative sign here. Remember, the signs must be different. Or you can just say m1 multiplied by m2 is equal to -1, and then your m1 is -2 multiplied by m1, which is equal to -1. Then when you divide both sides by -2, your m2 will be a half, because the negative and the negative will go. So this is the calculational method. Then this one requires you to observe. So we have the gradient and we have one of the points on the line, so we can find the equation. Let's use the first method. Y minus y1 is equal to m, then x minus x1. So you should pick your favorite method. You may not need all the methods. So for example, in a case where you have the gradient and one point, you can either use this or the gradient formula, but not all of them. So y1 here is 3, and then our m is a half, our x is still x, x1 is 2. So we can just expand and simplify. So we have half x minus, this one will simply be 2/2, and then when you take the 3 to the other side, of course this will be a 1, -1. Then when you take the -3 to the other side, you have this. So y is equal to half x, then this plus this will be +2, and this is the equation we are trying to find. And then let's go to part 2. So I got this from this past paper. This was someone's exam in 2023. This was paper 1, question 1. So we have the points A and B are -6,4 and -2,7 respectively. Find the equation of the perpendicular line to AB through the point B. So to find the equation of the perpendicular line to this, so it's like you have these 2 points. If this is your x or y plane, then -6 will be somewhere here, 4 somewhere there, then -2,7 will be somewhere there. So this line is like this, and then this is our A, and then this is our B. So now we've been told to find the equation of the line that passes through this. We know that it is perpendicular to that. So all you need to do is to find the gradient of this line, and then after finding the gradient of this line, we can take advantage of the fact that the gradient of this line is the negative reciprocal of the gradient of this line. And then we can find the equation knowing that we have a point on the line, this. So the gradient of this line is given by y is equal to y2 minus y1 over x2 minus x1. So our gradient will be, let's call this x1 y1, then x2 y2. So our y2 is 7 minus our y1, which is 4, and then our x2 is -2 minus our x1, which is -6. So our m will be this minus this is 3, and then negative and negative is positive, so we have -2 plus 4, which is a 2. So this is the gradient of this line. And then to find the gradient of this line, you know that the gradient of this line will be the negative reciprocal of the gradient of this line. So the reciprocal of this is like 1/3/2, which is like 1 divided by 3/2. So when you reciprocate this and multiply, you realize that you have 2 over 3. So when you have a case like this, you just swap the numbers so that you have 2 over 3. And remember, one of them must be negative. So since this is already positive, this one must be negated. So we have the gradient and we have one of the points, which is B. So the point B here is negative, actually B is this one, negative 2, 7. So we can find the equation with these properties. So let's use this method. So our y1 is 7, our m is negative 2 over 3, then x minus, our x1 is negative 2, like this. Then you can just simplify this. This times this will be negative 2 over 3x. Then this times this, of course this is positive, so this will be negative 4 over 3. And then you can take the 7 to the other side. By the way, this times this is positive, so negative times positive, this explains the negative. Then 2 times 2 is 4 over 3. So you have negative 2 over 3x minus 4 over 3. Then you take the 7 to the other side, you have this. And then when you subtract these, remember you need the common denominator. Let me write the 7 first, minus 4 over 3. So one of the shortcut ways of dealing with this is to just write the common denominator, multiply this by this, you have 21, minus 4, this will give you 17. So this is the equation we are trying to find. And then I think I'll leave this one with you. You can just try it out. I don't want to make this video longer than I have already made it.